Thanks everybody for coming. I'm a second year master's student here in the Silviculture and Applied Forest Ecology Lab at UVM under Tony D'Amato. And I'm going to talk to you about my research in recruitment dynamics of red spruce in our mixedwood forests in the northeast US. And I'm going to try to go really, really fast. So I'll first start by defining what mixedwoods are. So we're talking about forests that have a composition of hardwoods and softwood species. Specifically, I'm studying red spruce in the transition zone or ecotone between the high elevation spruce fir forests and the lower elevation northern hardwoods or beech maple birch forests. There's been a lot of interest by scientists and managers in trying to understand the benefits of our mixedwood forests. Some of those benefits include increased biodiversity values, greater structural diversity, more age classes, better wildlife habitat diversity, as well as a greater potential to produce timber and potentially greater resistance and resilience to climate change and forest health issues. And the way that I want to approach my research is by trying to understand the spatial and temporal recruitment dynamics of red spruce in these mixedwood forests. And by recruitment, I'm referring to the period in which red spruce regenerates back into the system. And so recruitment is this kind of long-term propagation of itself over and over again. So to measure that, I'm measuring both seedlings and saplings in our mixedwoods. And then eventually I'd like to use that information to inform management decisions on the ground. So here's an example of a mixedwood. This is from my site in the Adirondacks in Pigeon Lake Wilderness. I see multiple age classes of red spruce here. I know it looks really, really green, but just believe me when I say that. As well as yellow birch, some red maple, and American beech in the foreground. And there's some sugar maple, and then some younger red spruce and some beech. So one of the things about red spruce is that it's a great timber species, and that's also been to its detriment. One of the historical legacy effects of red spruce is that it was exploited from our forests from the 19th century into the 20th century, as you can see here in the Connecticut River in 1912. These are all red spruce logs, according to Tony D'Amato. And that exploitation has essentially unmixed our mixedwoods because it has disregarded future forest conditions. And there's been a range of other stressor dynamics on the systems, including spruce budworm outbreaks, bark beetle outbreaks, acid deposition, so pollution from CO2 and whatnot that have eventually led to acid rain on our forests. There's also been another range of other dynamics that suggest there may be recovery of red spruce, not just in our mixedwoods, but this is a graph from Foster and D'Amato, and that shows the ecotone between the spruce fir and northern hardwoods. And the purple is like the upper end of the ecotone, yellow is the lower end, and then the overlap. And it's suggesting that our advanced regeneration, so again seedlings and saplings, are moving down slope over time. So that's a good sign that maybe there's recovery occurring. There's also been recovery from other studies suggested from acid deposition. So my main research question is, what are the interacting ecological factors driving the recruitment of red spruce in our mixedwood forests? And so to do that, I'm looking at conducting a regional analysis using an FIA database data set. FIA stands for Forest Inventory and Analysis. It's done by the US Forest Service. And then multiple long-term continuous inventories from 5 different sites. And so here's another example of mixedwoods. It's a little harder to see, but it's there, I promise. And so here's what my FIA data set looks like. This is 2,600 some plots across the Adirondacks, Catskills, Tuggill Plateau, across Vermont, New Hampshire, and Maine. Those are all defined by having at least some red spruce in the overstory or understory mixed with hardwoods. And then my 5 CFI continuous forest inventory data sets from SUNY ESF, Dartmouth, and then 3 experimental forests from the US Forest Service. And to do that, I'm going to be using, in part, boosted regression trees, not to be confused with real trees. But it's similar to the way a decision tree is used, which marries machine learning and complex regression analysis to iteratively find the best predictor variables. and we can use that to also interpret interactions between variables. So speaking of interactions between variables, first of all, we try to find which variables have the greatest relative influence. So relative influence on our red spruce seedling abundance, or number of red spruce seedlings in the FIA data set is here on the bottom. And then I selected a few of the higher influential variables here. So seedling abundance is overall seedling abundance with all species. Relative density of red spruce, so the percentage of red spruce stems that are 5 inches or greater. And then longitude, stand age, and elevation. And then we can also look at those interactions between variables. So on the left side here, my fitted value is the response variable, or red spruce seedlings. And we see overall seedling abundance and red spruce relative density have a positive effect overall. And most interestingly to me is I see a rapid increase at 40% relative density with both overall abundance and red spruce seedlings. And so the other method that I'm going to be using is dendroecology, so it's tree ring analysis, to look at reconstructing spatio-temporal recruitment dynamics, so dynamics that are occurring in space and in time. And to do that, I took tree cores and measured trees using an intensive forest inventory system that included mapping each tree within the plot. And we took the tree cores like so, at about 30 centimeters above the ground. These are my technicians, Colby and Luther. And usually, as long as we get the pith, we can record the suppression and release events in the tree rings, and then try to integrate that with each individual stem in space. And so just real quick, show you where my sites are. This is Township 40, or the Adirondack site in west central Adirondacks. Long Lake, New York is the town. And then the Bull Research Natural Area, which is in the White Mountains in the south central area in Sandwich, New Hampshire. And then, so this is an example of my stem map. So this is each individual stem in one of my plots in New York. Black is the red spruce, gray is all other species, the circles are live, the triangles are dead, so I measured dead trees as well. And then we're looking at integrating the tree ring analysis with where these species fall in the plot to see if there's patterns and trends that we can analyze. This is our diameter distribution. This follows what we would consider a typical uneven age distribution. So this is kind of confirming this is an old growth and uneven age stand in part. And then a black again is red spruce, which is kind of takes up all of the diameter classes for the most part, which is pretty good. New Hampshire looked pretty much the same, although we had a higher abundance of lower diameter class. So as this research is ongoing, I hope to incorporate species functional traits, so the different traits that each species have that help it compete and survive. Looking at acid deposition is maybe having a legacy effect on our red spruce seedlings, so seeing if there's any historical evidence of interaction, and then fitting the better predictive variables into what we call structural equation modeling, which helps us measure direct causal relationships between variables, including between explanatory variables that actually give me an equation to measure that influence. And then eventually, I'd also like to incorporate with my long-term data sets change over time with recruitment. And then continuing with my dendroecology, finishing processing tree cores. There's 2,300 left to do. And then again, cross-dating them, so each tree ring from each core gets assigned a year and time. And then again, modeling that recruitment in space. And so I'm pretty much finished. I'd like to go ahead and thank my wife, Samantha Yerke, who I would not be here today, my committee, including my advisor Tony, Shelley, Ray, Carol, my incredible field technicians, Tom, Megan, Colby, Luther, some of my very helpful lab mates who helped me out, Peter and Tessa, and then a slew of other people, including the rest of my subculture lab, who have been incredible people, and my NR1 team, and our GSA. And with that, I will take any questions. We already have a question in the front. Olivia.
Well, with your dendro work, are you going to compare or add in any climate observations?
So we're actually choosing not to focus on climate observations with dendroecology. It's kind of the reverse of typical tree ring analysis or dendrochronology analysis, which dendroclimatology kind of being the bigger field where everything else is the noise except for the climate variables, and with dendritic ecology, the climate's the noise and all the other variables are what we're interested in. So, yeah. Tessa.
What might those variables be?
Which ones?
The other ones that aren't the noise.
So some of those variables may be site, so a lot of the same ones I'm using in the regional analysis, like site characteristics, competition, functional traits, that sort of thing. Nate?
2 quick questions. Do your FIA plots encompass the entire range of red spruce in New England?
Not the entire range, although they do fall mostly kind of within that,
Yep.
obviously, but they don't cover the entire range of red spruce. It's just, so a lot of the spruce fir, the pure spruce fir is selected out, and actually anything that, I've probably pared that down since that full set of plots, so where it's only selecting plots that have spruce fir and northern hardwood species in it.
And what about that paper by Brian Beckage et al., which shows the opposite result, I think, that red spruce is moving up?
Yeah, no, that's, so I know that there's been, that paper and a lot of other projections have suggested that red spruce will move up. But Foster, D'Amato, and Wasson and Doviak both have seen evidence that migration is also occurring downslope. So it's a great thing to kind of analyze and critique later.
Critique it now. Go for it.
Hopefully I'll figure that out.
Yeah.
Was it on purpose that the study sites, that was the one in New York and New Hampshire, that they're like the same latitude?
No, that was simply a function of availability. We just happened to find out about this old growth forest in New York a couple years ago, and by we I mean my advisor. And we then kind of learned about the Bull Research Natural Areas Mixedwood site by going and checking it out. And yeah, it is funny how they are,
Like dead?
yeah, almost straight line across, but no, it's totally by accident. Great. Thanks, everyone.
Thanks, Jordan.